Hello, my name is Rich Howard, owner of Architectural Builder Supply. This video is to bring you a closer look at the Folger Adam, part number 310-2-24D-630. This is an electric strike. It ships in this pretty large box. I think they kind of do that because the internal components are a bit modular. You know, they can pull the body and then the faceplate and switch that around, and it all fits into the box in smaller separate boxes. So this is the Folger Adam 310-2. This is, as standard, a fail secure strike. That means without power, the way you take it out of the box, it's locked. The only time the keeper is unlocked is when there is power applied. Non-fail secure, non-fail safe is fail secure. You can order these fail safe as well. Fail safe, when you take it out of the package, it's unlocked. It's only locked when you apply power. So fail secure is it's locked. Safe is it's unlocked, and that condition is premised on when you take the thing out of the box and you hold it in your hand. That's the condition. Not when it's wired, not when it's installed, but when you pull it out of the box. So this being a 310-2, it's of course going to have this pretty epic faceplate involved. Okay. Now this is a little bit of nothing unusual about this strike, but the thing that I would, as far as I'm concerned, when you're looking at strikes, the important things to know are when you're ordering one and you're replacing one. If you're replacing one, you have to know the voltage. That's number one. Is it, what volt is it? Is it AC or DC, and how many volts? That's absolutely crucial. They're generally DC, you know, obviously low voltage, DC. It's easy to tell the difference. Let's just assume that it's always low voltage, meaning it's going, I think the cutoff for low voltage is below 48 volts. Don't quote me, but we're going to bump into, in the DC voltage, we're going to bump into 12 or 24. And the AC voltages, you'll bump into 8, 12, 16, 24. Not sure what you have? No problem. Power the circuit. Does it buzz? If it does, you have AC. If it does not, you have DC. When you power the circuit of a DC strike, all you'll hear is a click. You know, put your ear to this. All you hear is a click. This will not move. It'll just click. So if you buzz, you have AC. Super simple. You still need to know the voltage. You know, you would want to have your voltmeter put onto the circuit and then energize or close the circuit, and then you'll know via your voltmeter what volts you have. But whether or not it buzzes, you'll know whether or not it's AC or DC. So we were talking about things that you have to know. You need to know the voltage. Now you know how. You'll have to have a voltmeter if you're not sure to test the power. If it is DC or if it is AC, you'll be able to set that on your voltmeter to tell which. You have to set the unit to maybe 200 on the dial. Don't quote me on that. I know I'm thinking in my head what my voltmeter looks like. Power the circuit, and then you'll see a number come up. You're testing the power. So when replacing a strike, voltage. When replacing a strike, what size is it? That's easy. You know, is this epically large faceplate what you have? I'm going to remove the solenoid assembly from the back of the faceplate, which just screws literally here and here, because they can put different solenoid assemblies into this faceplate. And that's going to be what we talk about in a moment. Overall height, 9-inch. Overall width, about 1 3/8. To the face, about 2-inch, and then the depth of that face, about 1.5 inches. Height, about 3 3/4. Then about 5/8 of an inch. Not that that really matters, because that will go back into the cavity of the jamb. So if you're replacing a strike, there you go. Does it match that size? That's what you need to know. So we've got fail-safe or fail-secure. What voltage? What size is it? The next thing that I think of two things. First of all, will the strike fit into the frame? Is it compatible? You'll note that this solenoid is straight down. The solenoid resides within here vertically. Okay. I learned the hard way, that a strike that is meant for a hollow metal frame will not work in a wood frame. I had a client one time order a strike, and I'm like, I got you all set, no problem. You want the Folger Adam? No problem. It's for a wood frame now, no problem, I've got it. Well, if it's a wood frame, that solenoid comes out and it sticks more like this, because there's no way to mortise a wood frame to be able to fit this into it. Yeah, there'd be no realistic way, and this is a somewhat poor example, but if you were to try to mortise the bottom of the frame for this, you'd have to hog out a lot of the wood to get this to fit in flat. Not ideal at all, because it's just simply going to be, you know, your frame is going to be cut out all through here to get that to fit in. A wood frame version of the strike, that solenoid, you just drill a round hole and you put that strike in. So what's the application? You know, is the strike, will it work for your frame? Will it work for a steel frame, aluminum frame, wood frame? So you want to be sure of that. The last thing that I can think of is the keeper depth. The keeper depth is tricky. It's how deep this is, the keeper. Okay, so better shown here. That's directly related to what lock you're using this with. What we have here is a 1/2 inch keeper. I think it'll take a 1/2 inch or a 5/8 bolt. If you have a mortise lock, any mortise lock, it's going to be 3/4 inch. This is the wrong strike. It might work, and I probably learned that one the hard way as well. It might work, but what happens is the latch bolt cannot project far enough so that the lock body itself is in a position where it can function correctly. If the latch is partially being pushed back into the lock case or the cassette, the lock may not work correctly. When you have too much latch bolt going into this keeper cavity and it's not able to fully extend, the strike may not be able to unlatch properly so that the lock body can be working compatibly with the strike so that the door can be opened. So that's an easy one. What's the projection of your latch bolt? Make sure the keeper on your strike will accept it. It's simple. If you have grade 1 or grade 2 cylindrical locks, that's going to work. Unless you have a 3/4 latch, which you could. Certain pairs of fire doors will say on the label, 3/4 min latch required, 3/4 min latch throw required. Unusual, but they're certainly out there. If, like I said earlier, if you have a mortise lock, any mortise lock, I shouldn't say any mortise lock. I don't know that a mortise lock from 1920 has a 3/4 inch latch throw. But any modern mortise lock, you need to be mindful of that. Exit devices with mortise cases, you need to be mindful of that, etc. And that logic applies to all electric strikes, you know, not just Folger Adam or her sister companies Hess or Adams Wright, but anyone's electric strike. You have to know that stuff. So there you go. So we've talked about the faceplate. We've talked about what this is. Now, where would you use it? This is going to be used in either probably a single door. You should be able to get this stuffed into a not sure how it'll work on an inactive door. We'll take a look at the template. The installation of this, I've got this in funny. I had that big. I had that in backwards. It's the depth of the keeper here. Sorry, I was showing it to you backwards. Okay, completely reversible, non-handed. You can turn that over. That dimension is equal from either end. Quick connector. The label. .310-2 24D630. We're going to dissect that part number here in a moment. What else is included? A wire nuts, a pigtail, and the 2 bolts to hold the solenoid package onto the faceplate. Then you're going to get your screws to hold that faceplate onto the hollow metal frame. Now, let's switch to the screen view and go over the supporting documentation. Okay, so this is the item that we are here looking at. Showing really the solenoid body only is what they're showing here, not the faceplate. By the time you're seeing this video, there will likely be images that have been added to this. And this can all be easily reviewed. You know, what's important here is that this is a grade 1 strike, which means it's the heaviest duty rating that our industry defines. It's 1 million cycles. Who knows how many cycles this strike would actually work. You know, if someone said this worked 18 million cycles, I would say, yeah, I completely believe that, without a doubt. In our part number, we've got the 310-2. This is a 24-volt DC in a stainless steel finish. This is cast. This item is cast. I believe it's cast stainless. I'm not an expert when it comes to metals, but it's cast in my opinion. Talk about different voltages, and I think what I'd like to do now is switch to all of the supporting documentation linked to down below this video, and let's go through them kind of one at a time. So what we have here is, here's what we have. The documents that are linked down below are going to be 2 versions of the installation instructions. The 2016 version, which came with the hardware, then the 2010 version, which is on the manufacturer's site. We're going to have those 2 versions of the installation instructions. I don't know what's different between them. There's clearly something different, or they would not have issued a revision. I'll be going off the 2016. We have a compatibility chart. We have a cross-reference chart. We have some dimensional drawings, and then a cut sheet. So let's start with the 2016 installation instructions. These are actually in the package, so this is what you're going to get. So simple and straightforward in the sense that here's what's in the box. Faceplate, solenoid assembly, 2 screws for the faceplate, 2 screws for the solenoid to go back to the faceplate. And by the way, once you order this, if you ever have a problem down the road and need to replace the solenoid, don't spend the money for the faceplate, assuming that it's perfectly good. Part number 4 is our plug-in connector. And the plug-in connector that's here is specifically for 24-volt DC. So the pigtail connector coming off the strike, you will then connect to part 4, and then you'll have your black and red, your positive and negative. Okay, so that's simple and straightforward. Electrical characteristics, which I will encourage you to look at on your own time, except that I'll point out a simple fundamental. As the volts go up, the amperage goes down. Okay, so be mindful of that. If you're designing a system and you're calculating your amperage required, you know, you might be pushed into using 24 volt over 12 volt because the amperage goes down. Okay, important to know what your ohms are in case you have a problem and want to troubleshoot the solenoid. If you're getting a value outside of that range, you'll know why. Now, minimum wire gauge requirements. This is incredibly important to know because, so minimum wire gauge requirements, I can't stress enough that this really needs to be adhered to. If you're looking at this, you might be a distributor, or you might be an electrician, or you might be someone who understands that the amount of distance between the power supply and the load, in this case the strike, is something that has to be understood. And what might be counterintuitive is how you need a thicker gauge wire as you go further. And what might be counterintuitive is that the resistance to the voltage goes down with a thicker wire. You need a thicker wire when you're running 12 gauge, if you remember, because there's more amps with 12 gauge. 12 volts. 12 volts. You need You need a thicker gauge wire with 12 volts because you're running more amps through it. I was called to a job site one time on a Saturday because their electric strike, after being installed for 2 weeks, just stopped working. And the manufacturer of that strike was a company that I have never had good luck with. But they ordered that strike because that's what they wanted. And so automatically I'm thinking this is a failed strike for whatever reason. Although hardware just doesn't fail. Anyway, so I go to the job site and I put my voltmeter on the power coming in. And, well, before I do that, I can see that the strike works intermittently in the sense that it had 2 keepers on the strike. Now, the bottom keeper worked just fine. The top keeper was getting held up. It wasn't releasing reliably. This was the entrance door to a 3-shift sort of production facility. And when you are clocking in and clocking out, you're doing so when you come in and out of that door. You're badging in and you're clocking in. So their employee time records were not correct. So I get my voltmeter and I see that I don't have enough voltage. It's close, but not enough voltage. I then go inside and I'm looking up and around, and it's 30-foot tall. It's precast construction, 30-foot tall, walls, and I don't see the power supply anywhere. Well, I can see the wires. And I can see the wires go up and up and up and up and up. And I can see the wires. So I start walking through this 100,000 square foot building, and I've walked 2/3 of the way down, and I realize, okay, I'm at several hundred feet. So I call the client. Don't get them on the telephone, naturally, because they're at their cookout barbecue. It's Saturday afternoon. I'm the only person in the world that's out there. So I get someone who's in charge there, and I say, where's the power supply? Oh, yeah, we moved that yesterday to the back of the building. I said, why did you do that? Oh, I don't know why they did it. They wanted it moved. They didn't want to see it there. So what happened was the power supply that was 20 feet away was now hundreds of feet away and was not serving the proper amount of voltage to the strike. I called the client back, left a voicemail saying this is what you need to do. There's nothing I can do here, and please let me know how it turns out. I've unfortunately, 10 years later, still have not heard back from that client. So be mindful. This is to be adhered to, absolutely. Okay. Now, UL 294 information. What its classifications are to that standard. Now what we're going to get, and these instructions are super easy. You're going to, the strike is probably already, the frame is probably already prepped. And if your frame is not prepped, we'll get to that in the next page, or a couple of pages in the instructions. If you were to have some monitoring switches, which you can monitor the latch bolt. And you could also monitor, so the latch bolt monitor is going to let you know the presence of the latch bolt. And if someone's trying to Lloyd the lock, you can add a locking cam monitor as well. There's multiple ways to monitor the exits, lock sets, things of that nature. Just because the latch bolt is in position doesn't mean the door's not been opened. So there are multiple ways to be sure or have report back the condition of the hardware. And an LC BMA, latch bolt and locking cam monitor, is one of those. Is two of those ways to do that. So if you have that, this strike does not. If it did, it would be clearly different inside the keeper area. Assembly is obviously quite simple. It does, of course, fit into your preparations. However, this faceplate is 9-inch tall and not 8-inch. What they're saying here, though, is what your mortise door prep, what your center line is. Forgive me. Here's what they're showing. This is 8 inch tall. This is the edge of a single door, or the active of a pair, of a mortise lock. Now, this does not apply to this strike because this is a 1/2 inch keeper. But if it was a 3/4 inch keeper, the dash 3/4, whatever your center line on the door, let's say for Seiko 7.0, I don't know, 42 and 7/16. Well, let's say Kiwani, that would be 43 and 15/16 is what it would be. I don't recall Seiko, but let's take a look. Contact us. Video gallery of all places. Scroll down to page 2. Scroll down, go to page 2. Then let's do a find function for hinge location chart. Hinge location chart. So our mortise lock prep will be 3/8 of an inch greater than our cylindrical lock prep, or 1/4 inch greater than our strike prep in the frame. And I was wrong. It's 42 and 7/16. I forgot what I said, but it's 42 and 7/16 for Seiko. You'll add 1/4 inch to this dimension, or you're going to add 3/8 to your lock dimension. Frame measurements, door measurements. So 40 for Seiko, 42 and 1/16. You would add 3/8 to that, and you're going to get to your 42 and 7/16. So the document that we're looking at here tells you where the center line of the strike needs to be in relationship to the center line of the lock body, dependent on the lock manufacturer. Okay, and this is, of course, a relationship between these two items. Where you place your tape measure is going to affect that. So if you're to measure the top of the door to the center of your prep, you're adding the B dimension. If you're going to stick your tape measure underneath the header and then come down to the strike location, that tape measure is going to be 1/8 of an inch longer. So be mindful to take that into account. They are not calculating that here at all. Okay. Now, why do you have to offset that? Well, the way that what you have, the reason you have a relocation of the center line is here's your lock body, here's your deadbolt, here's your deadlocking tab, here are your latches. Okay. In your strike plate, in a standard, that's an awful drawing, sorry. In your standard ASA strike, that is only going to be so large. You know, the size of that. Well, what they're, and I did not put this in scale, but they relocate the center line of the prep lower so that they can stuff all of this into this usable space. So the hole for a cylindrical lock in the strike would be in the center. But when you're doing a mortise lock, that hole is now biased towards the bottom of the strike because they're scooching all of that down because you got that deadbolt to stick in there. So that's why there's a relocation. Not enough real estate in the strike is the bottom line. If it was maybe a 5-inch tall strike, or, you know, not even that, you'd be able to just, you know, deal with it. But that's not the case. Here are those preparations that we talked about. 9-inch tall. You know, we took all these dimensions. That's what you need to mimic. You know, doing that in an inactive door, you certainly could. That's going to complicate what you might be doing with an astragal, obviously, when that portion of the faceplate is projecting off the face of the door. But it can be done. Just be mindful of that. You'll need to think that through. But if it's a double door, you might want an open back strike, which is what they're showing here. An open back strike is neat because you could have a pair of doors. An artist, he is not. And you could have a mortise exit device here. Okay, but the inactive door does not require an exit device. Well, what were to happen if the inactive door were to be opened and our active door closed first, you would have inactive door, and then your active door. An open back strike would allow this to close and not have the latch bolt interfere with the closing action. So that's what an open back strike is for. And again, just a different, you know, the 310-2 3/4, the U template. I'm not sure how that changes. It obviously does somehow. I won't take the time to discover that. 310-3-1, obviously a different faceplate configuration in the sense of what it is, where you can, it's a different function. You can discover that as well. And that's all that there is to these installation instructions. So there's really not much to say. It's an electric strike. And the things that I had said first in the video are really those important things. So we've got the 2010, the 2016 version. We then have the cut sheet, and here it is. Just a 2-page document, really, that will give you an overview of the different strikes. And what's nice about Folger Adam and other electrified companies like Securitron, Adams Wright, Hess, they give you the way to order it. Okay? And this is what I was talking about earlier. If you were to follow this, and if you were to say, I don't understand what something means, and you discover the difference, like in the keeper, 1/2-inch keeper, or up to a 5/8 latch throw, you might, if you were to say to yourself, what's the difference between the 310-2 and the 310-2 3/4, you'll see that's the difference. So this how to order keeps you from making a mistake, especially here. If you leave it blank, it's going to be fail secure, which is standard. The voltage, you'll notice that there are no AC voltages here. This is going to be DC only. If you are powering it with AC, you can. You'll need to order a rectifier. It's a very simple piece of simple piece of equipment that will allow the conditioning of the sine wave of the voltage, clipping it to the point where it can work compatibly with a DC solenoid. Your finish, and the only option would be to add monitoring to it. That's the entire cut sheet. Then we have a... this is the cut sheet. We just went over it just in a different format is all we did. I was looking at page 2. Okay, we can look at dimensional drawings, which we've gone over. Compatibility chart. So what cross-reference chart really? You know, if you've got a 310-2, what is it by Von Duprin? Well, here it is. That's handy to know. Allows you to go back and forth. This is a lock cross-reference chart. This will tell you what strike you can potentially use. I'm seeing just Hess numbers here. Yeah, this was pulled off of the manufacturer's website, this compatibility information. These are all Hess numbers. Not really appropriate to our Folger Adam. Okay, now let's wrap up this video. The link here to the manufacturer's page, that's going to allow you to review not only all of the Folger Adam products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. The name Folger Adam is synonymous with high quality, very, very high quality electric strikes. I think that there is a substantial loyal client base because the material is so completely robust. Older version of the catalog, not much else. Let's switch back to the camera view and then wrap up this video. Now, I think in this industry, everybody has, you know, especially locksmiths and door people too, everyone has electric strikes that they like and others that they will refuse to use unless they have to. I have that sort of polarizing, you know, attitude as well. I've just had jobs that didn't work out, and I had the one I said earlier about the distance of the power supply, no fault of the electric strike, but that was the same brand of another one that gave me trouble 5 years earlier. So, that brand just can't do anything for me. And it's not Folger Adam. I hear someone buying Folger Adam, I'm thinking you want something rock solid and dependable that you can install it and forget it. The only thing I would say would be a little unusual about this is that it's just for a 1/2-inch keeper, 5/8 maximum throw. Other than that, this would be a typical strike. And you're going to use a grade 1, heavy-duty, very expensive strike. You're going to have a equally robust lock set with it. That would be a mortise lock. That's why I question... that's why I ask you to question whether or not you need the 1/2-inch version of the keeper. Technical support at Folger Adam is shared with Hess, Adams Wright, probably Securitron. I think I have contacted that technical support department countless times over the decades, and they answer 100% of the time. A couple of times I had to ask twice because I'm like, no, that answer's not right. But overall, absolutely stellar. Folger Adam is under the umbrella of Assa Abloy. Her sister companies would be names like Medico, Sargent, Yale, Corbin, Russwin, Norton, Rockwood, Pemco, Adams Wright, Hess, Securitron, countless others, because Assa Abloy is a European, or maybe Scandinavian based. They get into stuff that we here in North America have really no idea what they're working on. So a lot of high security cylinder platforms are underneath their giant umbrella, and a lot of solutions. And they do a good job of also of making classes available. If you are a distributor, they have the Assa Academy. It's called something like that, where if you're a distributor, you can sign in and take webinars and classes and a full complement. They are constantly educating their client base, and because they want to, dominate. There are probably 4 major players: Assa Abloy, Allegion, Dormakaba, if that's what the name is now, and I think Hager wants to elbow in that into that tightly packed elevator cab, so to speak. And it's a race to get your products out there. When you've got a product as easy as Folger Adam, I think you don't focus on the cost because these aren't cheap. I think you focus on, you want that thing to be working in 10 years? Look at Folger Adam. Not to say that other people aren't, Von Duprin has an exceptional strike, but Folger Adam is, in my opinion, in that same conversation. Any questions on the 310-2 or any other Folger Adam product, please feel free to reach out to us. And thank you.